In this orthokeratology case, we're aiming for a multifocal effect, but the patient's got poor vision, distance, and near, primarily in the right eye because it's overcorrected. So we have a little bit of asphericity put in, and if we go to the back surface, we can see that the base curve does steepen a little bit right in the center of the lens to give us a little bit of a plus power effect. But I think what's happening here is our overall average base curve within the optic zone is a little bit too flat. We can see that our demand is up around 4.21, and I think that's a little bit too high for this case. A pretty good rule of thumb is if we remove the asphericity and we assume that the initial target power was 1.34, which is probably okay for this cornea, maybe a little bit high, but WAVE does calculate the average topo demand here at 3.56. And so after adding in the shape factor, usually what we'll want to do is readjust the base curve so that our topo demand is similar to 356 again. So we can just go to the red here, and we're going to steepen everything overall. And then a good thing to do is to check individual meridians, and our lens power is going to be a little bit different, but that's okay. That's because of the aspheric curve. But we want to be pretty close to 8.8 all the way around. So there's a little bit of discrepancy here. We can touch these up. We'll probably end up close to about a 1. This is in 25% mode. So there's a fair amount of manual adjustment still. Okay. However, our topo demand is a little bit low now, so I'm going to go back to 100%, and we'll bump this up a little bit. Okay, so 3.5 is pretty close to original. One more time, I'm going to just spin around here and make sure we're pretty uniform, and this does look pretty good. There's also a concern for poor comfort. In looking at the post-treatment topographies, it looks like the edge might be a little bit tight. So if we go out to the edge here, we're at 1634 microns. What I would do is just lift this up by about 10 microns, so 1624. And so you'll see a little bit more fluorescein around the edge of the lens, but that should make the lens a little bit more comfortable for the patient. What I would recommend doing is changing just the right lens first. The lens for the left eye has a little bit more asphericity, and I think that the increased plus in the center of the lens is balancing out the minus in the periphery of the lens, and the adjusted topo demand is similar to the initial Topman calculated by wave. So in terms of a refraction, the patient's doing a little bit better. The vision still isn't that great in that eye, but we don't have a very well-formed central steep area. There might run into a case where the patient just got a little bit too much going on in the center of the pupil. If this lens works out for both distance and near, what I would recommend doing is just mimicking this for the left eye as well. Or you can even maybe just decrease the overall power a little bit for a modified monovision effect. Last thing I noticed is pretty thin on this side. This is probably just wave automatically changing your center thickness when you might have changed one of your dimensions. But 18 is probably thin. I would bump up to at least 22 for center thickness so we don't get any flexure or warp on the lens. So those are my thoughts. Mainly it's just for the right eye. I would hang in there on the left eye and see how that topography forms over time and take it from there. So hopefully this is helpful. Best of luck with your patient.